Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is integration. What you are going to learn today is properties of integration. So let's begin. So after completing the very lesson today, my dear student, will be able to find the integral of a function having more than one term. That is, by making use of the properties that you have learned, you will be able to find the integral of a function that is having more than one term. This is what I hope you'll be able to do after completing the very lesson today. So as usual, my dear student, in your favorite segment of the lesson today, I'll give you one of the very first property of this Lucas sequence. And this property is linking the Lucas sequence or relating Lucas sequence with the Fibonacci sequence. We'll see a strong relationship between these two sequences of numbers after completing my lesson today. So don't go away. Now, to begin the lesson, let us just learn some of the properties of integration. So starting with the very first property, it says if you have the function y equals to c, where this c is just a constant number, just like you have a function y equals to 2, y equals to 5, and so on. If you have this kind of function, I want to find it is integral. So what did the property tell us to do? It says integral of this constant number with respect to x. The answer is now going to be cx. That is that very constant number. If it is y equals to 2, for example, then the integral of 2 dx, the answer is now going to be 2x. If it were y equals to 10, for example, and you wanted to find the integral of 10 dx, so the result is now going to be 10x. This is what this property is telling us. That is, integral of the constant number is that constant number, then attach the letter x to it. So let us move, take the second property. And the second property says if you have the function y equals to cx raised to the power of n. In this case, the number c is a real number and it serves as the coefficient of this term with the power n. So if you have y equals to, for example, 2x raised to the power of whatever, or y equals to 5x raised to the power of whatever number you have there. So, and you wanted to find the integral of this, what the property is telling us to do. It says the integral of this cx raised to the power of n dx. Remember, c is just a real number there, so it's nothing but c multiplied by the integral of x raised to the power of n dx. So you can now factor the constant number there, that is the real number, which serves as the coefficient of that very term. You can factor it out and you now find the integral of x raised to n, then that integral multiplied by the number c. So this is the second property. So let us move and take the third property of the integration. So the third property says if you have the function y equals to x raised to n plus x raised to m, that is, you have two terms there in the function y, where n and m are real numbers, and you want to find the integral of y. So what the property is telling us that the integral of this x raised to n plus x raised to m with respect to x is nothing but the integral of x raised to n dx plus the integral of x raised to m dx. That is, you have to find the integral of each term and whatever in between the two terms. You now, if it were addition, you now added the two integrals. If it were subtraction, you can now subtract the two integrals. So this is integration now term by term, if you have a function that has more than one term. This fourth property is just the same as this, but instead addition, you now have subtraction in the function y equals to x raised to n minus x raised to m, where n and m are just real numbers. So integral of this function y would now be equals to integral of the very first term minus integral of the second term. So you can now find the integral term by term, where you have the function asked to find it is integral has more than one term. We are going to take examples how we can make use of these properties and find the integral of some functions. So let us move Example number 1, we asked to find the integral of 4x raised to 3 minus 50x squared plus the 10 with respect to x, that is dx. Solution to this very problem. Looking at this very function, I can count 1, 2, 3 terms there. So I can now apply a property which says integral term by term. So let me just start. So integral of this very function, that is 4x raised to 3 minus 50x squared plus 10 dx. I can have 3 terms there like I have said. So using that property which says in finding integral of function that has more than one term, you can now find the integral term by term. So let me do that. So my first term is 4x raised to 3. So it will now be integral of 4x raised to 3 dx minus then integral of the second term, which is 50x squared. Look at it, integral 50x squared dx plus, it is plus that is separating second and third term, integral of the next term, which is 10 dx. So I'm now using that property which says integration term by term. So I continue. So looking at this very term, 4x raised to 3, this 4 is multiplying x raised to 3 just like a coefficient there. So using another property of integration where it says this 4 can be factored out, so you can now have 4 multiplied by the integral of x raised to 3 dx minus, I just copied this minus, then I move to the next term. Next term is also having 15 times x squared. So I can take this 15 outside the integral. So I'm going to have 15 multiplied by the integral of x squared dx. Look at it. I just take this 15, I factor it out. That is 15 times the integral of x squared. Then integral of this constant number. Remember, this 3 is just a constant number. Also using the property which says integral of the constant number. It is that constant number, then attach the letter x to it. So this integration of 10 dx, it will now give me 10x plus c. This plus c, it covers all other integral, because whenever we find the integral, we must write plus c. So we continue. So I now find the integral of x raised to 3. Remember the rule in our previous lesson, it says that the power will increase by 1 and you divide that very term by the power after increasing it by 1. So in that case, I'm going to have my 4. The 4 I have that is outside already. Then integral of x raised to 3 according to the rule in our previous lesson is now x raised to 3 plus 1. That power 3 will increase by 1 all over n plus 1. Remember that is 3 plus 1. Then minus. Then I'll move and find the integral of this x squared with respect to x. So there we have 15 already outside there, multiplied by the bracket inside is x raised to 2 plus 1. Look at the power is 2. So this power will increase by 1. That is why I have x raised to 2 plus 1 all over 2 plus 1. That the power, that is n plus 1. Then I'll just copy my 10x plus c. So I'll continue. So I'll now simplify those brackets. So x raised to 3 plus 1 will now be x raised to the power of 4 and over 3 plus 1. 3 plus 1 is 4. So I'm going to have 4 multiplied by x raised to 4 all over 4 minus, moving to the second bracket, the addition there, 2 plus 1 gives you 3. So you are going to have the 15 that you have outside times the bracket inside is x raised to 3 all over 3. Then plus, I just copied my 3x plus c. I continue. So I can now simplify this. You can see this very first term, 4 times the bracket. You can see this 4. There the denominator level will now cancel this very 4. So in the area you have just x raised to 4. Similarly here, this 3 can divide the 15 to get 5 there. So 5 times x raised to 3. So this is what I'm going to have finally. So I'm going to have x raised to 4 minus 5x raised to 3. Then plus the 3x plus c, which I just copied from here. The 5 here is 3 in 15. That gives you 5. 5 times x raised to 3 will give you x raised to 3. While this 4 cancelling this 4, you'll be left with x raised to 4. This is the integral of this very function. Let me just take one more example. Example number 2, it says find the integral of this function, and this function, it says x raised to minus 2 plus x all over 2 dx. Solution to this very problem. So copying the given task, that is in finding integral of this function x raised to minus 2 plus x all over 2 dx. You can see this is an algebraic fraction, and these two terms divided by 2. This 2 that I have here is nothing but 1 over 2 times this numerator. 1 over 2 times this numerator. So in that case, I can now factor 1 over 2 outside, because this bracket is nothing but 1 over 2 times x raised to minus 2 plus x. So let me do that. So I now have 1 over 2 multiplied by the integral of x raised to minus 2 plus x. You can see this is just your numerator. You have factor 1 over 2 outside the bracket, and that becomes the coefficient of the bracket, which you can take outside the integral sign. So we continue. So I now have 2 terms in the bracket, which in attempt to find the integral, I will now take a term by term. So I'm going to have my 1 over 2 times the bracket. Then inside the bracket, I now have integral of x raised to minus 2 dx plus the integral of x dx. So I'm now finding integral term by term here. We continue. So I'll now find the integral of x raised to minus 2 and find the integral of x, all with respect to x. So there I have my half that is outside already. Integral of x raised to minus 2, remember the rule. The power increased by 1, and you divide that very term by the power after increasing it by 1. So if I add 1 to minus 2, that is minus 2 plus 1. The result is now going to be minus 1. So this is the end result. That is, after increasing the power by 1, you now have minus 1 as the power. And you are dividing by that power after increasing it. That is, minus 2 plus 1 gives you minus 1. So you have x raised to minus 1 all over minus 1. Then plus the integral of x. That is the next term there, integral of x. This x has power 1. So that power 1 will increase by 1, so it becomes power 2. So you now have x squared there. Then all over n plus 1, and n plus 1 will be that 2. So you have x squared all over 2. Then plus the constant of integration. Don't forget to write this c all the time. So I continue. So I'll open this very bracket. I will expand it. So I'm going to have 1 over 2 times x raised to minus 1 all over minus 1, and 1 over 2 times x squared all over 2. So if you do that correctly, you are now going to have minus x raised to minus 1 all over 2, then plus x raised to 2 all over 4, then plus the constant of the integration c. This will now be the integral of this very function. With this, I have come to the end of this very lesson, my dear student. I hope you'll be able to find the integral of a polynomial function that is having more than one term. Let me just move to the last segment. I give you that very relationship between your Lucas and your favorite Fibonacci sequence. So this relationship says that the sum of any two alternate terms of your Fibonacci, that sum will now be a Lucas number. Let's just have a look at the two special sequence of numbers. This is your Lucas sequence, and this is your Fibonacci sequence. You remember that Fibonacci sequence start with 1, 1 as the first two terms, and other terms also are obtained by adding the last two. Addition of 1, 1 gives you this 2. Addition of 1 and 2 gives you 3. 2 and 3 gives you 5, like that. So these two sequences of numbers have a very, very strong relationship. And one of them is says the sum of any alternate terms of your Fibonacci. This is your Fibonacci sequence. If you add any two alternate terms, what you have as the sum will definitely be a term in your Lucas sequence. Let's just test it and see. So if I take 1 and 2 as my alternate terms, alternate means you skip one term, then you take the next. So 1 and 2 are alternate terms. And addition of 1 and 2 gives me 3. And you can see 3 surely is a term in your Lucas sequence. Let me get another alternate terms in the Fibonacci, 1 and 3. Addition of 1 and 3 gives me 4. And you can see 4 here is a term in your Lucas. Let me get another alternate terms, 2 and 5. 2 and 5 addition gives answer 7. And you can see 7 is a term in your Lucas sequence. And let me just take one more. 3 and 8. 3 and 8, if you add their alternate terms, if you add this to 2 gives answer 11. And you can see 11 is a term in your Lucas sequence. I believe for those that are familiar with the Lucas and the Fibonacci sequence, never mind to notice that this very, very strong relationship between the two sequences of numbers. We will see another relationship between these two sequences of numbers in our next lesson. So thank you for your attention.